So good morning, good evening, good afternoon, wherever you are. My name is Vishnu Dutt, and we are into the session number eight of our CCNA study, right? And in today's session, the agenda is going to be on routing. We are going to start routing fundamentals from today, right? In CCNA, basically, we do not have routing in much deeper, right? But whatever we have, that is still a huge thing for whoever is starting his or her career in networking, right? So we are going to talk about some cool things today. Okay. So for your information, we are done with the data link layer. Although if I say done with the data link layer, it doesn't mean that we have covered everything. But yes, whatever we need to know from CCNA perspective, we have covered most of the things, right? And that is why we are today moving towards the new thing, which is routing or the layer 3. I would request everybody to be please on mute. Having said that, we are not lost till yet. So where we are going to start from there. And here is the agenda. We are going to talk about routing fundamentals, the concept of next hop, static routing, AD, metric, longest match, floating routes. What are these, right? These are just the names. Do not worry about them. We will be understanding why behind them, right? And if you understand why behind anything, you can learn it effectively and easily, right? You must remember that we have created VLANs when we were talking about layer 2. Layer 2 is VLAN is the concept at layer 2, right? And as you know that from today we are starting layer 3, we are going to make sure that these VLANs communicate with each other, right? When we created VLANs over switch, you all know that we can create VLANs over switch, but these VLANs or anything which is inside them are not able to communicate with each other. Punish has shown all these things on the packet tracer too. The two VLANs cannot communicate unless they have a layer 3 device, which is the router, right? And that is why once we are done with this uh, basic routing concept, we are going to talk about that how these VLANs are going to communicate with each other. It is going to be very, very simple, right? And then at last, today we are again will be having a designer hat. And today we are going to design a small office network, right? Where there are maybe 5, 10, 15, 20 people are there, right? And how they are going to interact with each other, how they are going to interact with the internet. We are going to talk about it, right? So today's session is going to be very interesting and it needs little bit knowledge of IP addressing. And I believe that you have that knowledge because we have discussed everything in the few fundamental classes like this class 0 class 1. You all know about it, right? So this is the agenda. This is going to be the agenda for today's session, right? Now let's talk about where we are we again lost because we are learning so many concepts here, right? But believe me, at the end of the day, what we are doing here, when we started our journey, right, the problem is still the same. How to make two computers talk, we all know about it, right? How to make two computers talk, this was the problem. And we have divided this problem according to the TCP/IP model, and actually we are reading TCP/IP model. There we have a topmost layer, which is application layer. Then we have transport layer, where you know the TCP and UDP protocols are there. Then we have the network layer, where we see the IP is there, data link layer, where we most of the time see Ethernet. And that is why we learned MAC address. That is why we learned some of the problems associated with Ethernet and how to resolve them, like spanning tree protocol. We all know about it now, right? Physical layer, we are not going to discuss much more because it deals with how your bits are actually flowing over the medium, right? So as you know, the data link layer is just done. We are starting network layer today. So have this picture in your mind. If you forget that where are we with respect to complete picture of networking, we are right here. So somebody is giving us data, from the transport layer, and now it is the responsibility of IP layer to attach a header on top of it, which includes source IP address and destination IP address, and forward it towards the data link layer, right? So we are starting today network layer, which is the layer number 3, where a protocol which is widely known as internet protocol is there, right? So we are going to study about internet protocol today, or layer 3 today. Having said that, let's talk about the concept of next hop. And by the way, guys, whatever we are going to study today, we have been talking about it from long. For example, IP addressing, right? If a sorry for this, just wait a minute. So sorry for this. So we are here at the concept of next hop, right? So we have been talking about IP addressing for so long, and if you see somewhere /24, you all know that the host bits are going to be 8 and the network bits are going to be 24, right? It means that we can have 2 to the power 8, which is 256 hosts in this network, where first IP address and the last IP address is reserved. So the total number of hosts which can have the IP address are going to be 256. It is as simple as that. Sorry, 254, right? So what is happening here? We have a simple topology, very, very simple topology. We have one network here, which is 192.168.5.0. It means that this host, which is slightly inside this network, is going to have IP address from this range. Maybe this host is going to have 5.10 IP address, right? Right? It is as simple as that. So, so if we talk about another network, which is here 192.168.7.0, which is slightly far away from 192.168.5.0, right? Maybe here the host could be 7.20, right? And I am not writing the initial 2 octets, which are going to be 192.168.7.0. So what is happening here? Now we are talking about how these two hosts, one which is lying in network number 1, say this is my network number 1, and this is in network number 2, how these two hosts are going to communicate with each other. We have the high level understanding of it because we know that if two hosts are close together inside a particular network, then we need a switch. And if we have two hosts which are far away, which are into different networks, then we are going to have then we are going to have routers too, right? So what is going to happen at this router when we connect 192.168.5.0, which is the network number 1 here, network number 2 here, and network number 3 is also here, which is 192.168.6.0. It is as simple as that, right? So you all know for the fact that R1 is connected with 2 different networks. It means that somebody is going here on this interface of this router and configuring an IP address from this network. Otherwise, how come this router is going to understand that it is connected to 192.168.5.0 network, right? So somebody has gone here on the 0/1 interface of this router and it has configured the IP address 192.168.5.1. As you all know that the first IP address we generally give to the router on a particular network, right? So this is general saying. This is not the rule. You can give any IP address to the router interface, right? But generally, I have seen in most of the network, the very first IP address is reserved. It is reserved for router address, right? So somebody has configured 5.1 here, somebody has configured 6.1 here. Why 6.1? Because 6.1 is the first IP address. As soon as you configure this IP address, router's 0/1 interface knows that it is connected to a network which is 192.168.5.0/24, right? Why? Because it knows, because router understand this logic, router understand IP addressing, right? It understands that 0/1, somebody has configured an IP address 192.168.5.1/24. It means 192.168.5.0 is the network connected to it, because you all know that if there is a /24, then the first IP address is reserved for the network number. R1 knows about it now, that this complete network is connected with me, because if somebody has configured an IP address on me, that means that he wants to tell me that this complete network is connected to this interface. Interesting, right? Similarly, on R10/2 interface, which is this one, right? If somebody has configured 6.1, router understand that the another network which is connected to me is 192.168.6.0/24. It is as simple as that, right? Guys, can anybody confirm? I think there is a network glitch at my side. Are you able to hear me? Anybody can confirm, please?
Yes,
Yes,
sir.
Vishnu.
Okay, sorry for that. So here you go. Everybody understand that R1 understand that it is connected to two different networks, right? Router can learn about these networks from only two or three ways. To be precise, three ways. The first way is if you can go and configure this IP address on a router interface, right? And if we see what is happening inside the routing table, so basically just like a switch, a router also maintains a table which we call as the routing table, right? Switch stores MAC addresses, router stores IP address or IP subnets. It is as simple as that. So R1 table, what it is going to be looking like, right? R1 routing table. If you go inside and check it, and by the way, Punish is going to show you that how to check this table, right? So if we say 192.168.6.0, okay, I made a mistake. The first thing first, it is going to be 5.0. The 5.0 network is actually directly connected to me. This is a correct statement, right? Right? So whenever somebody configure an IP address on router interface, router is learning that this network is connected to me. It is as simple as that, right? Interesting. The second thing is, if somebody has configured 6.1, then router must be understanding that 192.168.6.0 network is connected to me. It is as simple as that, right? But here is my problem. How come this router R1 knows about this network, which is 192.168.7.0, right? This is not directly connected to this router, right? Interesting. If it is not directly connected to this router, then you can make it understand that it is connected to some other router, right? And you can reach it via some other router. What is the meaning? You can go inside router number R1 and say, Mr. R1, 192.168.7.0/24, there is another network, right, which is not connected to you. Very, very simple. Because if it had been connected to you, you would have noted about it. You would have informed about it, right? But it is not connected to you. So I am informing you. So who is I? I am somebody who can control this router, who can log in into this router and give some instruction to this router, right? Maybe I am controlling this router R1 and I am saying, Mr. R1, 192.168.7.0, there is one network which is not directly connected to you, right? But I am giving you more information about it, that if you want to go, if you want to meet, if you want to communicate something inside network 2 or 7.0, you can reach it via router number R2, because you can see this information. You have drawn this topology, right? if R1, router 1 wants to reach to network 2, which is 192.168.7.0, it has only one way to go, right? It can go from here to here and reach here, right? Interesting. So the way via which you are defining all these things, right? You are statically configure this router. What is the meaning of static? You are actually putting a static entry into its route table that Mr. R1 192.168.7.0 is reachable via R2. It means that if you want to reach to this network, you have to go via this router, which is R2, and this is going to be your next hop. What is the meaning of next hop? The meaning of next hop is that you are specifically defining here that Mr. R1 192.168.7.0, although it is not directly connected to you, but you can reach it via R2, and R2 is going to become your next hop because the packet, right, which wants to go to this network, which network? 7.0 network. If this packet wants to go to 7.0 network, it will be coming at R1. R1 is going to see that does it have any entry for 7.0, right? And yes, the entry is for 7.0 and which is available via R2. R1 duty is going to be, it is going to forward this packet towards Mr. R2, the packet which wants to go to network 7.0. It is as simple as that, right? And now R2, it is going to be very, very simple because R2 has this network directly connected with it, right? Because somebody has configured an IP address which is saying the IP address of this interface, maybe 0/1 interface of this router is 7 dot maybe 1, right? If that is the case, router R2 is going to learn this 192.168.7.0/24 network is directly connected to me. It means that when this packet reaches here, it is going to check against its routing table and it will find that there is a route, there is a network which is directly connected to it, and it is going to forward it like this one, right? Towards 7.20. But try to understand all those concepts which we have learned, right? Those are going to be intact here too. Layer 2 is not going anywhere, right? What is the meaning? Layer 2 is not going anywhere. The meaning is if you want to send this IP packet over this link, which is the Ethernet link, you need MAC addresses, right? It is as simple as that. If you need MAC address, then of course there is going to be MAC header, which is going to contain source IP and destination IP. It is as simple, sorry, a source MAC and destination MAC. It is as simple as that. Similarly here, if this router 2, because the packet is going to be like this, I am again writing the packet. Packet is going to be something which is coming from this network. Suppose it is coming from host 192.168.5.10. It wants to go to host 192.168.7.20, which is right here. So this is going to be my IP packet. We all know about it, right? But when router want to send it towards this 7.20, it knows that it is connected over 0/1 interface because somebody has configured 7.1 IP address here, right? But it doesn't know where to forward it because this is the Ethernet interface. And if this is the Ethernet interface, you have to configure source MAC and destination MAC here, right? And then everything starts. Router is going to ask who is 7.20 and 7.20 is going to reply. How it asks? Using ARP messages, right? So it has to complete this. Maybe the destination is maybe the MAC address is b.b.b. So it is going to write b.b.b here, right? And source is going to be whatever the source of this interface, because we all know the source MAC address gets changed on every hop. But IP address is not going to change. We all know about it. If these things are looking new to you, it means that you haven't gone through all the videos. Believe me, we have discussed all these things in greater detail. So layer 2 knowledge is there. Try to combine it with layer 3, right? Most of the time, if I say the IP packet is going, I'm not going to explain you that it is going with the help of Ethernet or whatever the media is, right? Most of the time, you are going to get this medium over which the packet is flowing the Ethernet wire, right? We all know about, we know the cablings also. It is very simple. So the point of this board is router creates routing table. The packet is going to be matched for the destination IP address. If we have the route corresponding to the destination IP address, definitely, definitely this router is going to forward this packet, otherwise not. Suppose if router 1 is getting a packet, say, which wants to go to 192.168.10.15, right? This is the destination IP address, which this destination IP address of this packet, which is received at R1. What should be happening here? R1 is going to match its routing table. It is going to see that I have only three routes. One is 192.168.5.0, and of course, 192.168.5.0, if you check this network, this host is not going to be part of that, right? Because this is 10.15. 10.15 is an IP address which is not part of this route number, this one, right? It is also not part of this route. It is also not part of this route. And if that is the case, this packet is going to be dropped right at the router number 1. Why? Because router does not have entry in its routing table. Router does not know how to forward this IP address. It is as simple as that, right? But if it has the IP address or IP network in its table, it is going to forward it. Maybe the IP address where this packet wants to go is directly connected to it. That is good. If it is directly connected, of course, this router is going to send it. If it is not directly connected, then it is again checking for the route and it is going to find, for example, if the packet wants to go to 7.0, it is checking that right now this route is not directly connected to me, but I am learning this route. Somebody has configured this route, that somebody is the administrator, has configured this route in me, right? Statically. And now this guy has specifically mentioned that if you want to send a packet towards 192.168.7.0, just go towards R2. It is as simple as that. And R2 is going to be my next hop. Concept of next hop is again very, very interesting because the packet goes hop by hop, right? Do not worry, routing is not complete. We have just learned about the routing table. We have just learned about the next hop. So router learns a particular route in three ways. Number one, connected route. And we all know about it. What is the meaning of connected route? The meaning of connected route, suppose I am having an interface R1 and I have a network connected to this interface and somebody has configured an IP address, say 192.168.10.0/24, or basically the IP address 10.1. That router understands this network is connected to me and we call such route as connected route, and you see an entry there with the name C, right? So if I write down the routing table of this router, it will going to say that the connected route is there, which is 192.168.10.0. The meaning is connected. Why? Because it is directly connected /24. And basically it is connected over this interface also. It is as simple as that, right? The second way a router can understand the route is by statically configuring that, right? We call that as a static route. Somebody is mentioning that there is another router R2 and there is a route here, maybe 192.168.30.0/24, suppose. And as an administrator, you are configuring this router R2, right? By logging into this router, right? And specifying that if you want to reach to 192.168, If you want to reach to 192.168.30.0/24, you can reach via router number R2, and maybe this interface is say 0/2 via 0/2. These routes are going to be entry with S. S means static. Punish is going to show you. Dhaval is going to show you. Do not worry about it. We can do, if you configure an IP address, it is going to be connected route. If you define it, it is going to be static route. There is another way, right? And the other way is basically for the smaller networks, you can straight away go into every route, right? Right? And every router and configure these through statically, right? But what is going to happen? Suppose there are so many routers. I don't know how many, right? And internet is full of routers. Do you think that this approach is going to be making sense? Suppose we have a network here, which is going to be 192.168.70.0. Suppose if that is the case, right? You do not know about all these things, right? That which route, which network is going to be connected where. So don't you think that these two approaches are okay to learn routes which are directly connected or basically in a small network? But what if we have a huge network? Then basically we need something through which we can learn this route on our own, right? What is the meaning of on our own? We do not want to learn these routes statically. We do, we do not want to
This will
configure
be.
all these routes, right? And if,
Sorry to interrupt, Vishnu,
yeah,
but there's a lot of disturbance on your end. Could you try changing your network?
oh, is it? Anybody else
Yeah.
can confirm this? Dhaval, are you getting the disturbance? Punish?
You are pretty clear for me.
Can anybody else say that what is going on? Maybe anybody?
For
Clear.
me also
It's
it
very
is
clear,
clear.
Vishnu.
Okay, then there is a problem at your end. Okay, just try
Okay.
to debug it. Okay.
Yeah.
So the third point is basically I was saying how this router can learn these routes on their own, right? We do not want to configure it statically. If that is the case, we want to configure them through something, right? Don't you think it is going to be great, absolutely great, if this R1 and R3 can talk with each other? R3 and R5 talk with each other. R5 and R6 talk with each other. R6 and R7 talk with each other. But what is the meaning of talking, right? As you all know, that if Rahul is here, Anjali is here, right? Then they are talking because they have some common language. Maybe they are talking in Hindi or English, but both of them should understand English or Hindi and the rules associated with that too, right? If they know the rules, if they know the language, then basically they can communicate with each other. If these router wants to communicate with each other, they should have those common rules, right? But the interesting thing is, suppose if we can make them talk what they are talking about, right? They are not going to discuss politics, we all know. Then what they are going to talk about? It is straightforward. They are going to talk about that I am connecting to these routes and here is this information, right? So wouldn't it be great that if R7 informed R6 that I am connecting to a network which is 192.168.70.0. If you want to reach this network or any host that belong to this network, just come to me. Similarly, R6 can inform R5 about this network. R5 can inform about this network to R3 that Mr. R3, if you want to reach 192.168.70.0, just come to me, right? And this is going to be my responsibility to forward it towards R7. R3 is going to tell the same information to Mr. R1 that Mr. R1, if you want to reach to 192.168.70.0/24, you can reach via me. right? And I am R3 over your interface, which is might be 0/3. It is as simple as that, right? These are dynamically learned routes. So shall I write D here? And the reason is no. Why no? Because the language we are going to talk about, right? R5 and R6, R6 and R7, through which they are talking, these language can be different, right? Like English, like Hindi, right? So there are different language in the networking world over which these routers can talk about. Some is, I think you have heard about the name OSPF. This is one language in which these routers can talk. Another language is RIP, REST, Routing Information Protocol. Maybe the EIGRP, Interior uh, uh, Enhanced Interior Gateway Routing Protocol. If you have heard about it, or you might heard about BGP also. You might heard about ISIS, right? So these are the languages over which these routers can talk, right? And language is associated with the rule. And if these two routers can talk in accordance with the rules, right, then we call such thing as protocols. So OSPF is a protocol which helps in routing. EIGRP is a protocol which help in routing. What is the meaning of it? It is helping in routing. If it is take a packet, right? So suppose if R6 and R7 are talking over OSPF, then they are going to send these routes. And believe me, in tomorrow's class, we are going to learn about OSPF, not in that great detail, but whatever is needed from the point of view of CCNA, we are going to talk about it. But if we are using OSPF in our network, then basically this letter is going to be O, which represent that the route is learned via a particular language, which is OSPF. If we were running RIP, then this letter is going to be R. If we are learning, if we had BGP, then you would have seen B symbol here. It is as simple as that. So how many ways a router can learn a route? Connected routes. It is as simple as that. Somebody has configured them, static route. And the last way is through dynamic routing protocol. Why we are calling them dynamic? Just run them, and after that, these routers are going to talk with each other. They will inform that I have this route. Send the packet if you want to reach it to me. That is as simple as that, right? If you guys have any doubt, any question on this board, please do ask, right? Okay. Having said that, let's move to our next board where we are going to define static routing. Although I have talked about most of it, but let's see it a little bit deeper, right? So by the way, guys, one more thing I would like to inform you. See, whatever we are covering here, the routing fundamentals, I have covered the same routing fundamentals in 13 hours, right? Over my website. So if you are interested, just click on it, because as you all know that we don't have much time, right? CCNA is a finite course and CCNA is not everything. But if you want to learn all these, means if something doesn't make sense to you, if you want to go a little bit deeper into it, I would request you to just have a look at the routing fundamental or routing from scratch at my website, right? So that's a 13-hour course, which we are going to cover here in just 1.5 hours, right? So it means that, believe me, there is lot more information. But that is again going to be, I have taken all these board from those classes. So if you are really interested, if you are seeing your career in networking, I would say register for this course absolutely free and start learning from that, right? Because you can understand, explaining 15 hours or 13-hour thing in just 1.5 hour, I am deliberately leaving some things. Okay. Having said that, let's talk about. We are seeing here a router. The topology is very, very simple. We are seeing here router number R1 here, right? R2 is here, R3 is here, and then there is a network which is 10.10.10.0/24, right? If it is a /24, you all know about it. It is going to have 254 legitimate IP addresses, and out of them, I have one host here configured 10.10.10.10/24, right? And interestingly, I have included one more subnet mask in this topology, which is /30. By the way, guys, don't you think that there is a network between R1 and R2 too, where only two hosts are there? Which host? R1 and R2. It is as simple as that. I'm talking about this network, which is straight cable, right? Interesting. There is no switch between R1 and R2. There is only two hosts. Those are directly connected with each other over a cable. You all know whether it's going to be crossover or straight through, or maybe you do not care about it. Just put any cable. But I have specifically mentioned that the 10.20.20.0/30. What is the meaning of this 30 here? The meaning of this 30 is that I have only 2 bits for my host. 2 bits can give me 2 to the power 2 means 4 numbers starting from .0, .0, .1, .2, and .3. And out of them, these two numbers are going to be my network number, and my broadcast address is going to be .3 because there are only 4 hosts in this network, right? And why I have done this /30? The reason is if I had done /24, suppose I would have wasted so many IP addresses because I know that there are only 2 hosts in this network, right? If this is the case of /24, if I have taken /24 here, then the number of hosts would have been 254. Out of them, I am using only 2. It means that 254 IP addresses are going to be wasted. If that is the case, it is not good. And that is why I'm using /30, because /30 is actually giving me exactly 2 numbers, .1 and .2, which can be used. So I am configuring 20.1 here, 20.2 here. It is as simple as that. Similarly, if I have given an network 10.20.20.4 believe me, 10.20.20.4/30, this .4 is not an IP address given to a particular host. No, this is the subnet number. Why? Because if I am having /30 here, it means that I am having only 4 hosts, right? Starting from .4, .5, .6, .7. If that is the case, I have only 2 number which I can give, right? .5 and .6. Why I can't give .4 and .7? Because the first IP address is always going to be my subnet number, and the last address is going to be the default gateway. Not sorry, the mask. So the last address is going to be the broadcast address. It is as simple as that. So .5 I have given here, .6 I have given here. So I believe that you all understand the IP addressing whatever I am giving, right? So in the standard customer network, if you see /30, that is going to be perfectly fine because customer is frugal about his IP addressing, right? He does not want to waste much IP addresses. If that is the case, it is very, very simple to understand this IP addressing, right? And if somebody is throwing a topology diagram at you, make sure you give it a proper time and then ask question. It is perfectly to ask for 1 hour, 2 hour to just go into this topology diagram to understand the IP addressing, to understand what customer is running, and then ask questions. Because this is the thing which I feel is missing in most of the network engineers, right? So having said, because if you understand this diagram, you can ask good question. You have a pretty better understanding of customer network. And if you have a better understanding of customer network, you know that you can do wonders. Having said that, what I want to explain here is that I have specifically gone into this router R1. Who I am the administrator of this R1, right? And I have logged into this R1. What is the meaning of logging in? The meaning is I have the console access of R1, right? And R1 is giving me a command prompt, and over that command prompt, I am writing something, right? And that something is basically I'm giving this router R1 few commands so that it can take those commands into its configuration. Punish talked about the running configuration. He also talked about I think Dhaval has talked about the running configuration, the startup configuration. Now what I'm going to do is I am logging into this router to guide him that Mr. Router R1, if you want to reach to 10.10.10.0/24, right? Or you can write this way also 10.10.10.0 255.255.255.0, then it means that you are saying this network is reachable through this guy. And who is this guy? 10.20.20.2. 20.2 is this one, means R2. It is as simple as that. Interesting. So you have statically configured this router routing table, and this routing table is going to have a static route which says the 10.10.10.0/24 network is reachable via R2 and R2's IP address, right? And whatever the IP address of R2 is 10.20.20.2. It is as simple as that. So this router is going to have this route. Similarly, if we talk about R2, again, I am logging into R2 and then giving this command. And router R2 is going to create its routing table. And it will be saying that 10.10.10.0/24 is reachable via R3. And R3, again, this is going to be static route. And R3's IP address is, of course, 10.20.20.4. Interesting, right? So now let's have a packet path, how it is going to be there, right? So I have defined two static routes, at one at R1, the other at R2. Let's see how the packet is going to be forwarded on the basis of these static routes, which I have configured on R1 and R2. I have an IP packet here. I do not care from which source it is coming. Say x.x.x, maybe a network is attached here, which is x.x.x.0/24, and then there is a host here, which is sending the IP packet. But the most important piece is the destination IP address. The destination IP address of this packet is actually 10.10.10.10 right here. You all can see that this 10.10.10.10 is right here in this orange network. We all know about it, right? We can see the topology, but how these routers are going to know about it? And we have let them know through the static routing. It is as simple as that, right? So what is going to happen? Router R1 will see the destination IP. Destination IP is going to be 10.10.10.10, and it will try to find that whether it has this host part of some network in its routing table, right? It is going to check the route. It is going to see that yes, it is having a specific route which is 10.10.10.0/24. It knows the calculation that there are 2 to the power 8 hosts in this network. right? Means 256 hosts are going to be in this network from dot 0 to dot 255, and 10.10 is somewhere in this range. It means that where this packet wants to go, I know that there is a network which contains this host, and if I want to send this host, it should go to first via R2, and R2 is 10.20.20.2. I will be forwarding this packet from here to here. It is as simple as that. Now this packet reaches here, which is having the destination address. Source can be anything. The destination is 10.10.10.10. Again, the logic is going to be simple. Again, we have the IP packet. Router is going to see the destination IP packet, destination IP address. It is going to see that it has the route of which this IP host is part of, which one, 10.10.10.10, right? Here. But if this packet wants to go to reach 10.10.10.0 network, it has to go to R3, which is having IP address this one, 10.20.20.4. It will be forwarded here. It is as simple as that. But now the packet is at R3. Source is going to be same. Destination 10.10.10.10. And by the way, guys, layer 2 concepts are still here. When the packet flows over this Ethernet network, it is going to be encapsulated in Ethernet frame, right? But I am removing that thing, right? Because we understood all these things. If you do not get it, I would advise you to see all the videos, right? Today we are having session number 8. We started from 0, so there are 9 sessions, right, which are available on the website as well as YouTube too, right? So the packet R3 is going to reach here, 10.10.10.10 is the destination. And now if I write down the router's R3's table, it is going to have this connected route. Why? Because the FP0/2 has this network, right? Maybe somebody has configured 10.1 here. It means that it is going to say the 10.10.10.0/24 network is connected to me over 0/2 interface. It is as simple as that. And once this packet reaches here, the IP packet the process is going to be same destination IP address. Destination IP address is lying in this network. It means that the R3 is going to forward this towards this. It is as simple as that. So we are actually guiding every router in the middle using static routing, right? This is the static routing which I've configured. Interesting, right? So I think we understood now what is the static routing is. We can definitely define these things, right? And if we are talking about the routing table, then the routing table is going to contain this route definitely 10.10.10.10/24 via R2, right? Suppose the another thing is from this R2, complete internet is connected. Suppose. What is the meaning of complete internet is connected? Here you have all the routers of Google, Amazon, Chat, GPT, anything, whatever you would like. Everything is here on internet. It is not the single cloud, it is multiple clouds combined together, connected together, similar in the similar way which you are trying to do, right? Everything is here. If that is the case, and suppose we have 1,000 networks here, or maybe 1 lakh network here, it is going to be very difficult for the administrator, right, to configure all these routes so that the routes can be, so these packets can go for example, suppose this packet want to go to google.com and the IP address associated with google.com, maybe Amazon, maybe anything else. You can't write all these IP addresses here, right? Statically at least. So what you need to define? You can define that you have to define that if you want to go to this internet, you only know one thing, that the internet is reachable over R2. It is as simple as that, right? So you need to forward all the packets from here to R2, and that is it. R2 is connected to the internet. R2 will take care about it. How R2 is going to take care? That's a whole soul different game. How R2 is going to learn all these routes, right? Maybe through BGP, or maybe it is running some routing with the service provider. And whatever the last statement I said, just forget about it, because we are not going to learn it. But for sure, whatever the packet, wherever it wants to go, whether 10.10.10.0, or whether you have your next stop only R2, right? You do not need to worry about it, where they are going, because whatever the routes you are connected, you are going to forward the packet, right? And for everything else, R2 is your gateway. As simple as that. So what we can do here is I can configure a route, IP route 0.0.0.0, right? And the mask is going to be 0.0.0.0. By the way, if we define a route this way, this represents all IP addresses. Everything is going to match to this route. IP route, this should go to 10.20.20.2. We call such routes as the default route. And whatever the next hop I am giving here, that will become my default gateway. It is as simple as that. Why default route? Because it is matching all the packets, right? Why default gateway? Because if I do not know where to send the packet, I have at least somebody to which I will forwarding, and it is his responsibility to forward the packet. Maybe this router also doesn't know how to read. Then maybe this router is going to destroy or uh, finish this packet. It cannot forward it unless it is going to have the route. But I just wanted to make sure that you understand that if somebody is defining 0.0.0.0, it is going to be 10, it is going to what 10.20.20.2. And by the way, we have mentioned this thing when we were talking about layer 2 also, right? We all know that we have this complete network, layer 2 network, where we are having so many hosts, right? And if these hosts A, B, C, D, E, F wants to communicate with each other, of course, there is a need of switch. Through all these hosts are connected to this switch, and that is why they were communicating with each other. We all know about it, right? But suppose this wants to go over the internet here, right? Here is my internet, all the Google server, Amazon, Cisco, anybody, right? What I need to do, I must have something which is a router. Suppose this is my network 192.168.10.1 slash 0/24. So this guy is also connected with switch. 10.1 is given here, and I have configured a default gateway here, or the gateway. Remember those TCP/IP setting which we opened in case of Windows Ethernet setting, and we defined here that if you want to go anywhere, the default gateway is going to be 192.168.10.0. Actually, what we were doing there is that, boss, if you want to go to 192.168.10.0 network, it is right there, right? All the hosts belonging to that is there, right? But if you want to go anywhere else out of this network, go via this router. It is as simple as that. Because this is the router which is the gateway to all other networks, maybe internet or anything else. So by the way, at that point of time, in these hosts also you were defining that if you want to go to 0.0.0/0 for all zeros, we also call it the quad zero route. default route, whatever you want to say, you can reach it via router number R1, which is 192.168.10.1. It is as simple as that. Interesting. Okay, and thank you so much, Dhaval. You are answering questions. Thank you so much for that. And thank you so much, guys, for asking the questions. Having said that, we are done with respect to default routing also, right? And of course, in the routing table, whatever the routes you see here, these are the route. We call them networks. Of course, routing table composed of what? Routing table composed of networks. It is as simple as that, right? I would like to give you another example because there is a concept of one more thing which is important. Okay, let's take an example. If I say I have a network which is 192.168.10.0/24, the meaning is it is going to have 256 hosts, right? If I say 192.168.10.0/25, it means that I am going to have 128 hosts. This network is a bigger network. This network is divided into two parts, and this is the first part of this network, starting 128 addresses, right? Interesting. If I say 192.168.10.0/26, there are going to be 64. Don't you think that I can go and write here 192.168.10.0/31? 31 means only one bit, means 2 to the power 1 host in 2 hosts. And at last, if I define 192.168.10.0, right, /32, I do not have any host bit here, right? But if I say 2 to the power 0 is equal to 1, it is not 0. So basically all these are networks /24 or network routes, I can say, right? Router can install all these things. Router can install this entry too, right? 192.168.10.0/32. This network is defining 256 hosts. This is 128. How many hosts this is defining? 32, right? /32. How many hosts this is defining? Only one. Which one? This one only. 192.168.10.0. And if we say that, this is going to be my host route. Host means it is identifying only single host or entity, right? If you get that, that is fine. If you don't, that is perfectly fine also, because you will be seeing the we will seeing all these things later also. So having said that, let's move to one of the most important concept, right? And I see today's engineer also have problem when we talk about AD and we talk about different concept in terms of longest match. What is the meaning? Do not worry about it. We'll let you know. Okay, so right now, what we are doing is we are explaining you some of the nitty-gritties and the concept associated with layer 3, how router actually forwards the packet, right? We have talked about static routing. We have talked about how to configure default route, how generally router forwards a particular route, right? So we have a router here, which is R1, and I'm throwing some problems at you now, right? Which are going to be very, very interesting problems. Okay, so suppose I have R1 and R1 is having this route, which is 10.10.10.0/24 directly connected over it, right? FA0/1, and somebody has configured an IP address 10.1 on this interface. It is straightforward, right? But interestingly, somebody else has also created the same network which I am using, right? And that is having 10.10.10.0/24. Interesting, right? This network, network X, and this network, network Y, both are absolutely same. Both has same number of hosts also. 10.10.10.0/24 means 254 configurable IP addresses, and same here. It is as simple as that, right? But if that is the case, then we are meeting a certain specific problems. What are those problems? Let me write it down here. That if this network is directly connected, I am going to have the connected entry into this routing table, which is going to say that 10.10.10.0/24 network is directly connected to FA0/1 interface. It is as simple as that, right? And now I am the administrator also. I am playing with this router, right? And I have mentioned that this is the route. This is the static route which I want to give. So now this guy is going to have one static route also, which is 10.10.10.0/24. Maybe I'm saying it is connected to R2. Suppose this guy, right? And R2 is basically, you can write via R2, this one. Interestingly. And then suppose a routing protocol also informing me the same thing, right? There is another routing protocol, which is say here, which is OSPF. This is again saying 10.10.10.0/24 is reachable via R2. And here is my problem now. The problem is which route I'm going to believe, number one, number two, or number three. Interesting, right? Here the most important part is the network is same, 10.10.10.0/24. I am learning the same network through different sources. One is through connected route, another one is through static route, and the last one is through OSPF. If that is the case, which route I'm going to select, which route should go into the routing table, right? I do not want to make this router confused, right? So for your information, how to select, how to prefer a particular route is based on the fact, based on a number, which is known as administrative distance, right? This is the number. The lower the number, more preferred the route is. Interesting, right? So one thing I would again want, and this is the most important thing, the route should be exactly matched. Route should be exactly replica of each other. But yes, if we are learning them from different sources, maybe static, maybe connected, maybe OSPF, or any routing dynamic learning protocol, right? If that is the case, I am going to select the route which is having less AD value or administrative distance value. So I have written down the AD values also. For connected route it is 0, for static route it is 1, for OSPF it is 110. So of course, the route which is going into the routing table is going to be the connected route, and these routes are not going to be there at all, right? And somebody very clearly did this, all this, right? Of course, if a route is directly connected, if a network is directly connected, I am informing router, right? I have configured 10.1 here that Mr. Router, this router is directly connected to you, and and that is why it is having the more preference, right? Because it is giving me most credible information. Then a static route is coming next to it because I am configuring it, right? Previously, router knows that this guy is connected to me. So I'm giving static route at 1. OSPF has having the administrative distance value of 110, and so other protocols too. For example, if this router is learning a route from OSPF, the same route from BGP, the same route from the RIP, which route is going to be preferred? The preferred route is going to be the one which is having the smallest AD value. It is as simple as that, right? Suppose through some reason, right? Suppose through some reason, if this network is down, somebody has plugged this cable out from this interface, this one is completely down, then we are not going to see this connected route for sure, because router is learning this connected route because we have configured the IP address, but now this interface is no more. And if this interface is no more, that we are not going to see this route in the routing table. Which route is going to go into the routing table? This route. And of course, this is not going to go. Why? Because static routing is having the more preferable AD value, which is 1, than OSPF. It is as simple as that, right? We are not talking about metric here for now. And the reason is the metric is defined when we are going to start reading dynamic routing protocol, which is OSPF, and I will be including that. And it's my mistake that I have included it here. Okay. I think if this board is clear, I think there is nothing pretty difficult about this board. This board is pretty much self-explanatory, right? If that is the case, the next board is going to be slightly problematic for many of us, right? Doesn't matter how many years of experience we have, we always face issue when we discuss this thing, the next topic, whatever I'm going to talk about now. Okay. For now, to begin with, suppose we do not have this interface plugged in and we have Mr. Dhaval Patel here, who is administrating this, who is the administrator of this router R1, and he's playing with R1. What he has done, he has defined 4 static routes: static route 1, static route 2, static route 3, static route 4. And interestingly, those routes are this one, 10.10.10.0, 10.0, 10.0, all are looking same. But are they same? Are these routers same? Sorry, are these routes same? No, absolutely not. And the reason is we have /24 here, /25 here, /26 here, /27 here. And this is the most common problem which everybody face. People say, if we have these 4 static route, which route should go into routing table? Believe me, guys, all the routes should go into routing table. Why? Because these routes are not same. These routes are different routes. It is as simple as that. People says no, the one which is having the longest prefix match is going to into the routing table. No, absolutely not. Every route will be installed here in the routing table, right? Because previously, as I was mentioning, in case of administrative distance, this route was same. The route was 10.10.10.0/24. If you are learning this via OSPF, via BGP, via anything, if you are learning the same route, then you are going to check the AD value, right? Suppose if this route has AD value of 1, this is 10, this is 30, this is 40, suppose. And if somebody says that only S1 will go into the routing table, no, it is absolutely not a correct statement. Why? Because S1, S2, S3, S4 are totally different routes. And if these routes are totally different, then everybody should go into the routing table. But yes, if the route is same, then we need to check whether the AD value, which have the most preferred AD value, right? But here is the thing. Now I am going to have 4 different routes in my routing table, which is going to say the IP route 10.10.10.0, 0/24 is reachable via R2, this one, right? Why? Because I have switched off this interface. I have shut down this interface. This interface is, this network is not here, suppose, right? This is going to be my first static route 1. Static route 2 is going to be 10.10.10.0/25. It is going to be via R2. S3 is going to be 10 dot, just wait a minute, guys. Yeah, 10.10.10.0/25, sorry, 26 via R2. And I am going to have S4 also, which is going to have 10.10.10.0/27 via R2. It is as simple as that, right? But why I am talking about all these things? This is fine. We understood the difference between AD and the different routes. We all know about it. But the problem is, what is going to happen when the packet comes? Suppose a packet is going at the destination address. The source is going to be, suppose, anything, x dot x dot x dot x, and the destination is, say, 10.10.10.10. If this is the destination, which route is going to matched by routing protocol? Sorry, router, right? So this packet, suppose this packet, IP packet, comes here, right at this router. Which route is going to be consulted? S1, S2, S3, and S4. This is the problem. Basically, if you see that this 10.10.10.10 is part of this network, this network, this network, as well as this network, then which route is going to be preferred, right? Because it might be the case that this R2 can be somebody R3, which is totally different router. Say R3 is this one. Suppose this could be the case, right? I have defined this route like this way also. So where this packet should go now in this condition, whether it should go towards R2 or it should go towards R3, this is the question. The question should not be that which route should go into the routing table. All the routes are going to be in the routing table. Why? Because these routes are different routes. But which route is going to be consulted if we want to send this packet to 10.10.10.10? This should be the question, right? And to understand that thing, we need to go back to the again to the IP addressing, right? So we have 4 different routes, right? I would like to draw like this. The first one is actually 192.168. Sorry for this. Sorry. 110.10.10.0/24, right? The first network was this one. You all know that we are going to have from here 0 to 255, right, in this network. But if I divide it by 2, then I'm going to get 10.10.10.0/25, which means it is going to have from 0 to 127, right? And now I am again going to further subdivide it into 2 parts. Then I am going to get 0 to 64 or 63, right? Which is going to be your 10.10.10.0/26. And then basically, if I want to divide it more, then we are going to get this one, right? 0 to 32, which is going to be 10.10.10.0/27, right? So basically, we are dividing a bigger network. So if I draw this diagram once again, right? So I have that complete network. Sorry for this. I have this complete network 192. Okay. 10.10.10.0/24, and then inside that I have another network which is 10.10.10.0/24. Inside that I have another network which is 10.10.10.0/26, and inside that I have the last network which is going to be my /27. Here we are having 256 hosts, here we are having 128, here we are having 64, and here we are having only 32, right? But yes, the inside network is part of this one, means we can say this is a superset, then all these are my subset. It is as simple as that, right? But the question remains same, which route is going to be followed? Who is giving me the most specific information about this 10.10.10.10? If I say the most specific information is given by the smallest network, which is this one, right? Because although 10.10.10.10 is part of /24, it means that all 256 hosts were also part of this. It is also part of this green one. It is also part of this one. But it is also part of this one, right? But the last network is going to give me 32 host information, where my 10.10.10.10 is. It is actually giving the most specific information. It is not providing me information about 256 hosts. It is providing me information about 32 hosts, right? And 10.10.10.10 is part of that. And that is why I'm going to get this route to forward the packet. If you do not get it till now, let's bring one more analogy. Now let's say we have Mr. Rahul, right? And Mr. Rahul lives in India, right? And suppose somebody wants to go and meet Mr. Rahul, right? And that somebody is Mr. A, suppose, right? Rahul addresses house number 196 or 396, Prestige City, which is in Bangalore, which is in Karnataka, which is in India, right? And then in Earth, and then Earth is a part of the solar system, although you can increase, right? Suppose this guy wants to go and meet Mr. Rahul, Mr. Rahul. Mr. A wants to meet Mr. Rahul, and he is getting addresses from 3 different ways, right? Address number 1 he got that you can definitely meet Mr. Rahul and he lives in solar system. Interesting, right? Of course, this information is correct. The second guy came and he's saying that Mr. Rahul lives in solar system, in Earth, and in Earth he is in India. Again, this is interesting information, right? And of course, this is correct information too. And somebody is saying that Mr. Rahul lives in solar system, in Earth, in India, in Karnataka, in Bangalore, in Prestige City, and in 396, right? Which information is going to be most useful for you? Although all these 3 information are correct, all these 3 addresses are correct. The information which is absolutely correct, which you are going to believe and you are going to work toward it, right? Mr. A is going to work or want to believe is going to be third because it is totally defined, this guy, right? It means the more the information you have, it is definitely easy for you to find Mr. Rahul. It is as simple as that. And that is what these guys are doing, right? /27 network is going to have more information, right? Why? Because it is not talking about 256 hosts. It is not talking about solar system. It is talking about inside the solar system, right? We have a group of 32 hosts and 10.10.10.10 is part of that. It is as simple as that, right? So if we have connected any other router, which is R3 here, right? And if somebody wants to go this way, and suppose if this route is configured here via R3, and if this packet reaches at router R1, this packet, it is going to be meshed again this one, this one, this one. It is going to be meshed again only static route 4. Why? Because it is going to give me more information, and that is what we known as longest match routing. What is the meaning of longest match? We just see who is having the most bit in network. The most bit in networks are going to be 24, 25, 26, or 27, 27, because 27 is the network bits. And if we have more network bits, then definitely we are going to have the lesser number of hosts. It is going to give me the most specific information, right? So longest matches or longest subnet mask is going to give me the most specific information about that route. And that is why we are going to match the longest route. It is as simple as that. Believe me, 80 versus longest match is a long-term debate, and this debate is going to be over right now if you understand these two concepts. Having said that, Mr. Dhaval, Mr. Punish, do we have any question?
Yeah, Vishnu, we had few. I have answered.
Perfect.
Just one question from Monica. She mentioned that how can two networks of 254 hosts with same network ID
Mhm.
exist in administrative distance example?
Okay, that is basically okay. I will tell you an example. Suppose this, and this is a good question. This is a great question too, right? Suppose I have a network here, Monica. Suppose this is 10.10.10.0, right? And this network is connected to this router R1, right? And then basically this network is also connected to another router, which is R2. We have redundant network, means we have redundant router. That is perfectly fine. That can happen, right? And then basically we are connecting them with another router, both of them, like this, R3, right? And suppose we are, these guys knows the OSPF, these guys knows language through which they can talk about their network. So R1 is going to advertise that 10.10.10.0/24 is connected to me. And suppose here we are running EIGRP protocol, suppose, right? And then R2 is going to say that 10.10.10.0/24 network is connected to me. Now R3 is going to have two routes. One is learned via OSPF, the other one is learned via EIGRP. These are just the protocol, right? Just the languages for now, you understand, right? It is going to say via OSPF we have a route which is 10.10.10.0/24 reachable via R1, and again 10.10.10.0/24 reachable via R2. Which route I am going to believe in? Did you get the answer, Monica? Although definitely we should not be having the same network in two places, otherwise it is going to break our IP. But because routers are connected in such a way that we may learning the same route from two different places. Okay. So any other question we have?
No, Vishnu.
Hello, Vishnu.
Yeah, Monica, go ahead.
But you showed in two different networks like network X and network Y with the same network ID, right, in administrative example?
Yeah,
Can you show me the
yeah, this one, right? Oh, no, 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 this one, static routing. Just wait a minute. Just wait a minute. Actually, it is getting slow. I think this one, right?
Yes.
Yeah.
yeah, this one
So
on.
basically here, the I just wanted to explain you the concept, right? And if you do like this also, Monica, means if you have two routers, you can create a network like this. There is no doubt about it, right? But yes, this network is going to be incorrect network. The complete topology is going to be incorrect. But here, I just wanted you to explain the concept of administrative distance, right? That you can learn the same route from various ways. Maybe somebody has configured it incorrectly. For example, suppose R1 is Mr. Dhaval's responsibility and R2 is my responsibility. I also like this network. 10.10.10.0 is my favorite. Dhaval also has this network, so maybe they can accidentally configure it and we can see all these things here, right? Yes, the network can be accidentally configured in a wrong manner. That is perfectly fine, right? But yes, in those cases, we are going to see such issues which are going to be resolved by network because IP protocol needs to work. It doesn't depend on what you are configuring, right? Whatever you have configured, it has to have a definite way to move forward. And in this way, if you are just see, I am doing a lot of wrong thing here. See, this network was directly connected. I was also saying this network is actually connected through static, and I am also receiving through dynamic. It is not going to be the case all the times, right? Somebody have misconfigured, then you are going to get this. But learning networking is not about all the times learning the perfect network. You need to understand imperfection also, so that you need to do debugging, right? You need to inform, just like you are informing me, Mr. Vishnu, you are wrong. You have configured two different network with the same thing. You need to inform customer also like this. Is it fine, Monica?
Yes, Vishnu, it's fine. It's all about that we can get the routing information from two different routes. That's it.
Yes. If we get the routing information about the same network from two different routing protocols, which we need to select, which is chosen by administrative distance. The lower the administrative distance, the more preferred the route is. Okay?
Okay, Vishnu, thank you.
Yeah, but thank you so much for the question. And now we are actually, I think we are done with 1 hour and 30 minutes. Interesting where the time goes, I do not know. Maybe you guys are feeling more about this time that you guys can feel, but I literally didn't feel that 1 hour 30 minutes have been passed. So let's meet. Let's meet at 11:34, and we are going to start again some cool things. I'm just stopping the recording for now. So welcome back, and we are going to talk about few more things with respect to routing. And here it is going to be load balancing and floating static routes. Again, these are just the names. But yes, definitely we need to understand the terms, what these are. If you get the concept of administrative distance, if you get the concept of longest match routing, I do not think that understanding anything with respect to routing and what are the concept we are going to discuss today is going to have any problem. Okay, so let's talk about the topology with whatever we have here. Right now, if you can see, we have an orange network, which is right here, 10.10.10.0/24. Okay, and we have router R1 here, router R2 here, router R4 here. This is my router number R3. Okay, so we have introduced one more router, and I leave everything to you with respect to the IP addressing, right? Somewhere I am using /24, somewhere I'm using /30. You can see, but anything, whatever I'm using, I'm pretty sure that you now are comfortable with the IP addressing. Having said that, what we are going to talk about here is the concept of load balancing. What is the meaning of load balancing, right? Suppose I have a packet, I'm not sure from where it is coming, but say it is coming from x dot x dot x dot x network. This is going to be my IP packet, and it wants to go to 10.10.10.10 right here. Okay, and I have for now just forget about this number, whatever I have written here. So right now I have two routes. I have specified two routes, static route number 1 and static route number 2 here. Okay, and routes are same. IP route 10.10.10.0/24 FA0/0, right? And 10.20.20.2. The meaning is if you want to go to this network, you can go via R2, which is having 20.2 IP address. This is the static route number 1. The static route number 2 is going to be IP route 10.10.10.0 can be reached over this interface FA0/2, or the next hop is going to be 13.2, which is this one, right? So if I see the routing table of router number R1, we are going to see two routes. That 10.10.10.0/24 is reachable via R2, and also 10.10.10.0/24 is reachable via R4. If that is the case, I haven't defined any administrative distance. These are the static routes, so the both by default the administrative distance is going to be 1. What if in this case, if we have two routes which are exactly same installed into the routing table of router R1, on what basis router 1 is going to forward this IP packet towards 10.10.10.0, right? Interesting. Suppose two packets are coming, one is with x.x.x.x source address, and the other is going to be say y.y.y.y. It is coming from this source address and destination is same, again 10.10.10.10. What is going to happen? We are going to match these two destination IP address, whatever we have in the routes, right? Both the routes are matching. It means that both the route have the same preference, right? Because we do not have specified any AD value in this case. So the packet can go out over this interface and packet can go out over this interface too, right? So in such cases where we have the same route, we have the different next hop, we do load balancing. We send some packets over here, we send some packets for over here, and that is perfectly fine. Because at the end of the day, these are going to reach to R3 and will be delivered to this host, which is 10.10.10.10, right? But on what basis we define which packet should go over 13.1 and which packet should go over 20.1, right? We presume we understand that over these link, 50% packet should go here and 50% packet should go here, right? So does it mean that I am going to send the very first packet here, the second packet here, the third packet here, the fourth packet here? It could be one of the approach, right? We call it a per packet load balancing. But believe me, this is not efficient. What we are going to do is that it is not going to be the case that from the source x.x.x to the destination 10.10.10.10 there is going to be one packet. Maybe there could be 100 of such packets which are going into this direction, right? From this source, and maybe there are 100 of such packets which are maybe 20, 30, 50 packets which are going from y.y.y.y towards 10.10.10.10. If that is the case, what we are going to do? So there is different approaches of balancing the load. One is we are sending one packet out of one interface, the other is out of other interface in a round robin fashion. The other approach is whatever the packet belongs to the same flow. If I'm saying same flow, for your understanding, it is going to be with the same source IP and it is going to the same destination IP. And there could be many packets. There could be many such packets. So basically, what we can do is yellow packet can be sent over here, and the green packet can be sent over here, which is having the different source IP addresses, right? It could be the load balancing on the basis of source IP, destination IP, or whatever we can have, right? But I wanted to tell you the important piece of information is that if there are multiple packets wants to go to the same destination and we have the same route in the routing table via two default gateways, or sorry, via two different gateways, one via this one via this one, we can send the packet, we can balance the load, right, over path number one, over path number two too, right? This is as simple as that, right? But suppose if I do not want to do the load balancing, what I can do now is I can right now, what I want to do is I want to have R2 as my path, which should always be there. Okay, for example, we have Mr. Rahul here, and Mr. Rahul has created this complete network, and his boss came and he is saying, and he has put some requirement that Mr. Rahul, now you are doing load balancing. You are sending some traffic from R1 towards R4, some traffic towards R2. I do not want this. What I want is that all the traffic should go via R2 towards this, right? And if something happened to this interface, something happened to this interface means if this link goes down, then you consider sending this packet over the different link like this, right? So he is saying his boss want to say that the path number one, which I'm going to, which I'm showing in the pink color, it is going to be my primary path. I will be using this path, right? And the blue color path is going to be my secondary path. And the reason his boss is giving is that this interface is actually 10 gig interface. Suppose this is up and running, right? And this interface is only 1 gig interface. So we can send more traffic over the below interface than the above interface, right? This is my path number one in pink color. Path number two is in blue color, which I do not want. But yes, if something happens to this 10 gig link, then this path should be up and running. How we can do that? We can definitely do this. See, this S1 path, which is the pink color path, because it is having the destination, because it is having the next stop at 10, 20, 22, which is R2, right? It is going to have by default AD value of 1. What I'm doing is I am going to specify the value, AD value for the below route, and suppose that is 35. I can straight away write this number while writing this command to make sure that this is having value 35. Now, R2, now static route 1 is having AD value 1, static route 2 is having AD value 35, and you all know for the fact that the lower AD value is going to be preference, right? The route with lower AD value will be going into the routing table. It means that this route will be eliminated from the routing table. This route is going to be installed in the routing table. And if that is the case, we are going to choose this pink path to forward the traffic. But if something happens to this route is actually into the configuration, right? When this route is not there, then of course we do not have a choice, right? Previously, we need to choose from the route because both routes were same 10.10.10.0/24, one with AD value 1, one with AD value 35. We have chosen only one, which is via R2. But now this route is gone. We have only route with AD value or administrative distance value 35. If that is the case, we are going to forward this packet, right, over 35 because this route is not there, and then this will be eliminated because somebody has taken out this route or maybe this interface is down. And if that is the case, we are going to take the below route, which is having AD value 10.10.10.0/24 via R4 will come up with the AD value 35. Why? Because there is no other route. And we are going to send traffic over this path. It is as simple as that. And that is what Mr. Rahul's boss wanted, right? So I think you should have understood the concept of load balancing, plotting static routes, right? And by the way, again, I am reminding you that all these concepts has some more information, some more theory behind it, but everything cannot be covered in CCNA, right? If you want to learn more, you need to spend more time, right? But where you are going, but if you want to have the similar sessions like this, the whiteboarding, if you like the whiteboarding, then I would suggest my sessions to you. Again, I am saying, by the way, everybody means I have given, and that was a mistake from my side. Now, whoever has registered, I think we have given more than 100 people to site access. What you need to do is you just need to go and log in into the website bridgewire.com, right? With your username, whatever you have given the Cisco username. And then once you are into this website, you need to find CCNA course. Just go to the course section and enroll it. The meaning of enroll it, that we understand that now you want to study CCNA. We have already given permission to access CCNA. Once you click on enroll, you will get a button like start learning, and then you can start all the sessions, right? So whoever has registered the website till now, they have got the access, right? So all those videos, today's video, around 9 videos along with the hands-on. So theory portion is given in the theory session, and whatever the hands-on portion, whatever we have packet tracer, right? The session given by Dhaval, Punesh, those are there in the hands-on sessions, right? But I would say just repeat, and along with that, you are going to get access of other things also. Means if you want to run routing fundamentals, some security concept, there are so many things there if you want to learn anything, right? But yes, I would advise you to just complete routing fundamental course there, routing fundamental from scratch, because I have covered everything in 2 hours. There we have more than 30 hours of contents, right? Do not limit yourself with CCNA. That's what I'm saying. If you are learn all the concept fully. But I have a specific timing requirements, right? I cannot go more than that. So having said that, let's talk about more.
Hey Vishnu,
Mhm.
Hemant Raj has raised hand.
Yeah.
Hemant, you have any query?
No, no, I'm just checking whether my bridgeby.com access is enabled or not. In between, the hand is raised by mistake.
Okay. So if you guys have any doubt, any problems that you are not able to access, just ping me on the Teams, sorry, this WebEx Teams, and I will be responding to that. Okay. So having said that, now we are moving towards combining layer 2 with layer 3, right? You all know that on the switches, we can create the VLANs, right? Everybody knows that. But inside those VLANs, if we have put two hosts, host A, host B, which are part of two different VLANs, then they are not going to communicate with each other, right? Why did we created these VLANs? So that if this guy sends a broadcast, it should be remain, the broadcast should remain in its own VLAN. It should not disturb to other guys, right? It is as simple as that. The aim was not that the marketing should not be able to communicate to engineering. No, it was never the intent. The intent was to limit the scope of broadcast, because you all know that address resolution messages, request messages were sent to the broadcast address, and if we do not divide this complete ports of the switches, then whoever is connected to the switch is going to get the broadcast, which is not needed, right? Which is disturbing other uh, endpoints or the hosts. But now if we see here, what if we have a requirement that these people who are in VLAN 10 should be able to communicate to people in VLAN 20 and VLAN 30. What do we need to do? We all know for the fact, we all know that switches cannot understand IP address. For switch, basically we send them an IP packet, and inside these IP packet, we encapsulate these IP packet into the MAC header or the layer 2 header, which is having source MAC and destination MAC, and this switch only forward by seeing these source MAC and destination MAC. It doesn't understand IP at all, right? And interestingly, if this host A, suppose host A wants to communicate to host B, then of course it is going to do the ARP and everything, and it can communicate using the MAC addresses, right? Without any doubt. But now, suppose VLAN 10 is having a subnet which is 10.10.10.0/24, say. This is having a subnet which is 10.10.20.0/24, say. And we are having here 10.10.10. Sorry, 30.0/24, right? We have three different network with respect to every VLAN, right? Of course, switch can able to make them communicate. I mean, A, B, C can communicate with each other. D, E, and F can communicate with each other, right? And G, H, I can also communicate with each other. There's no doubt about it. But what if 10.10.10.0 wants to communicate to 10.10.20.0? Switch does not understand, right? This thing. And I cannot put, suppose host A, which is in network VLAN 10 and having the IP address say 10.10.10.10 wants to communicate to 10.10.10.20 or 20.0, sorry, 20.10 machine somewhere here. Maybe this machine is 20.10. What is going to happen? In VLAN 10, of course, switch knows that 20.10 is not part of my VLAN 10. If it is not part of my VLAN 10, then rules of TCP/IP says that of course this host is not part of my own network. It is part of some different network, right? And switches does not understand different networks. And that is why I need to ask somebody to forward this packet to 20.10 network or 20.0 network, right? And the somebody should be layer 3 device, right? And the layer 3 device is the router. See what I am doing here. I am having three interfaces on the router. 0/1 interface, 0/2 interface, 0/3 interface. And of course, we have three interfaces on the switch too, right? This interface belongs to VLAN number 10. This interface belongs to VLAN number 30. This interface belongs to VLAN number 20. It is as simple as that. Right? Guys, just wait a minute. Yeah. So what we are doing here is that we are taking three interface from the switch perspective. We are having VLAN number 10 here, VLAN number 20 here, VLAN number 30 here. We have configured these interfaces, right? We can do that. We all know, right? Similarly, these interfaces are in VLAN 10. We all know these interfaces are VLAN 30. We all know this is in VLAN 20, right? But what we are going to do here at the switch on the router side, I am going to configure the IP address, which is the first IP address of the VLAN 10 network, 10.10.10.1/24. This is on 0/1. On 0/3, I am going to configure 10.10.20.1, the first IP address /24, right? And on this route, this interface, which is 0/2, I have configured the another IP address from the VLAN 30, the first IP address 30.1/24. It is as simple as that. It means that this router is going to learn three connected routes now, right? One route is connected over its 0/1 interface, the another one is connected over 0/3 interface, and the other one is connected over 0/2. 0/1, which route? You all know 10.10.10.0/24 is directly connected to me over 0/1, right? Similarly, 10.10.20.0/24 is directly connected over 0/3. And at last, 10.10.30.0/24 is directly connected over 0/2. It is as simple as that. We'll know routing now, right? Interesting. Now, what I've done here is that if this 10.10.10.10 wants to go to 10.20.10, right? It knows that the destination is in different networks. So I have configured the default gateway or the gateway on this host that your default gateway is 10.10.10.1, right? Remember the TCP/IP thing, TCP/IP Ethernet seeding, and I have mentioned their gateway is 10.10.10.1. It means that now this packet first will go to this router, right? 10.10.10.1, and you must be thinking the packet is going to be over this switch. Then how this switch is going to be forwarded? Because the packet will be going towards the destination MAC address of the router itself, right? Router is having 10.10.10.1 IP address. The MAC address, suppose, is say c.c. No, not c. Let's say the MAC address is maybe a.b.c. Suppose any arbitrary number. So the source of this is going to be a.a.a because it is coming from here. The destination is going to be a.b.c. But where a.b.c? How this machine get this number, right? A.b.c. Again, the same process, ARP. ARP is going to be broadcasted. It means that it will come here, it will come here, and of course it is go here also on switch this green port, right? Why? Because it is part of VLAN 10. ARP will be going to every port of this VLAN 10. It means that it is going to received by L3 port, right? Over this router's green port, and router is going to reply with the ARP reply message that my address is ABC, and that is why it is going to create this one, right? And now switch is learning in the CAM table that inside VLAN 10, right? It has three entries, you know, VLAN 10, VLANs, MAC addresses, and then interfaces. Then, of course, it should be learning A.A.A. First of all, VLANs. So VLAN is going to be your VLAN number 10. The MAC address A.A.A is connected to whatever this interface is. Maybe this interface is 0/1, suppose, right? Again, VLAN 10. B this A.B.C is connected to whatever this interface is, maybe 0/2 router interface, right? Switch is learning this. So when this packet reaches here to the switch, switch is going to be forwarded towards the green port like this, and the packet will be reaching to this router. Now this is the router, it can understand, of course, the MAC address, because if it is an L3 device, it can understand L2 as well as L1. It is going to see that, okay, the packet is for me because it is ABC. ABC is my MAC address. It is going to open this packet. It will be remaining with this packet, right? 10.10.10.10, and destination is going to be 10.20.10, right? Where it should be matching it? It should be matching it with the routing table. Routing table have these three entries. The packet is going to go to 10.20. Something, right? Here, it means that this router is going to send this packet out of 0/3 port, right? Interesting. The packet will be here. Of course, after placing this packet here, it needs to append the layer 2 header, right, by doing the ARP for this, wherever it wants to go. But I'm not going into this process because you know, right? Interesting. So what is the packet path going to be? If I remove everything from here, and if I want to show you the packet path, right, with the red color, the A packets are going to be first thing first will be reaching to this router. Over the router, it get been inspected against the routing table, and then basically from here, it will be reaching here. It is as simple as that. If VLAN 10 wants to communicate to VLAN red, again the packet is going like this. Over this red link, they are coming back, and then they are going to communicate. It is as simple as that, right? If anybody is having any doubt, any problem, please do ask. Mr. Dhaval, am I audible?
Yeah, Vishnu, you're audible. There are no questions as such.
There are no questions. Okay. Right. But as you know that we are continuously making this process efficient. Believe me, routers interfaces are costly. Right? What is the meaning? Switch interfaces, for example, switch you can easily get 48 ports, right? But getting a 48 port router is a big deal, right? So these three interfaces, right? What these are doing, right? Suppose if we have 20 VLANs, then what? Then 20 interfaces of routers are going to be in this means for this inter-VLAN routing. And by the way, guys, we know this term because now the VLANs are talking, we call them inter-VLAN routing, right? Because VLANs are talking with the help of this layer 3 device, which is the router. But my problem is, what if we have 20 or 200 VLANs configured? Then it is going to be problem. Why problem? Because I need to have 20 or 200 interfaces on the switch just for this communication, so that it goes to the router. Router decides on the basis of the routing table, it comes back, and that it is, right? It is not efficient at all. Let's make this solution efficient. Mr. Dhaval is going to prove that this can be made efficient, right? How we are going to make sure that we do not waste so many interfaces if we have 20-30 VLANs, right? And that is where the concept of sub interfaces come into picture. Sub interfaces? What is the meaning of sub interfaces? We are going to combine, right? We are going to use only one interface, maybe 0/1, right? This is the physical interface, but we are going to call it at 0/1.10. This is going to be my first virtual interface. Then 0/1.220, this is going to be my another interface, and 0/1.30, it is going to be my other interface. But yes, one physical interface can be divided into multiple virtual interfaces. Interesting, right? If that is the case, then we can connect only one interface between this router and the switch, and it can do the job. Because we all know for sure that with respect to switch, it's not going to be a problem. Why? Because if we make this interface as trunk at the switch side, then we can send multiple VLAN traffic. VLAN 10 can go, VLAN 20 can go, VLAN 30 can go. We have solved this problem using trunk, right? At the layer 2 level. But how at layer 3 level? Because our router R is going to give IP address here, right? And if there is only one interface, how it can give the IP address? Interesting, right? So what we are going to do is we are going to divide this one interface into three parts, three different interfaces. But the problem is we have only one physical interface. So whatever these interfaces are coming, these are logical interfaces or the sub interfaces. So sub interfaces, whatever we are creating out of the physical interfaces, are going to be logical interfaces. And then we can configure three different IP addresses, right? And that is what we are going to do on the next board. If you see here, now I do not have three interfaces. Whatever you are seeing inside the color green, red, and yellow, The traffic is going on the over one interface. Suppose this is router's interface number 0/1, right? So this router's 0/1 interface is going to be divided into three parts, right? This is going to be 0/1.10. You can choose any arbitrary number, but this is always going to be useful that if you use the .10 to specify that the VLAN 10 traffic is coming here so that you are sure, but this number could be anything. Here you can define 0/1.20. Sorry, the middle one is 30. So let's say this is 30, right? And then 0/1.20. We have divided one interface into three different interfaces, and now I can give IP address here, right? This IP address is going to be 10.10.10.1/24. This is going to be 10.10.30.1/24, and this is going to be 10.10.20.0/24. And if I give that, router is going to be busy in creating its routing table that now 10.10.10.0/24 is directly connected route, and this is reachable over 0/1.10. Why? Because router understands the sub interfaces. Again, another connected route 10.10.20.0/24 is going to be connected with 0/1.20. It is as simple as that. Connected route 10.10.30.0/24 is going to be connected 0/1.30. It is as simple as that. Now we are using one interface. And over the switch also, suppose this is 0/20th interface, right? Suppose any number, we will make it trunk, right? So the VLAN 10 traffic, whatever is going on, it is going to have the IP header and then layer 2. And you all know that inside this layer 2, what we are going to do, we are going to send this packet is for VLAN 10, right? But for logically, router is going to receive everything on 0/1, right? How router is going to understand that this is for 1.10, for 1.30 or 1.20? And that is why we need to make sure that we do some configuration. So what we are going to do here is on routers 1.10 interfaces, I am writing .1q. This IP address is 10.10.10.1, right? And after I am writing this 10 value, right? What is the meaning of it? Just try to understand. The problem is actually when this switch is going to forward this frame, right? The VLAN 10 frame towards the router is going to learn, router is going to say that at the end of the day, guys, you all should understand that although we are having the virtual interfaces, but at the end of the day, we have the one physical interface where this packet is reaching, right? Towards this router. It is going to reach at 0/1. How do I come to know that whether it should be 1.10, 1.30? I need to inform the router, right? Right? Router should understand that you should be understanding that the switch is sending .1q header, right? Where inside this .1q, what we have? We have the VLAN number or the tag of that VLAN 10. And that is why I'm defining here that for 1.10, use tag 10. It means that router is going to say that if a frame comes with tag value of 10, it is for 1.10. It is as simple as that. And then we are going to configure this IP. Similarly, when this router wants to send the packet out of 1.10, it will make sure that the IP packet is going to be encapsulated into layer 2, which it always does. But after that, it is going to include this tag value of 10 so that when it reaches to this switch understand that this is for the VLAN 10 and that is why it is going to forward this here. Then that is why your bidirectional communication is going to happen, right? So switch is sending to router the tagged value. Router is sending the switch to tag value so that they understand, right? But the important piece is that we have done some magic here. Instead of using three different interfaces, I'm using only one interface, which is actually forwarding, which is we are using for the inter-VLAN routing. It is as simple as that. If you do not get it, I would say revise the concept where we have talked about trunk, where we have talked about .1q tagging, right? If you do that and you see this video or this class, it is going to make more sense to you. And Mr. Dhaval is going to showcase this inter-VLAN routing, and we call this as a router on a stick configuration. Why? Because if you can see this router, this is looking like this is placed on a stick, right? Interesting. Router on a stick configuration, Mr. Dhaval is going to give you, right? But try to understand one thing, that why do we need extra router here? Why can't we do something in this switch itself so that switch will do inter-VLAN routing? Interesting, right? But here is my problem. If I need to do routing between these VLANs on the switch itself, if I do not include a router, then I need to make sure that this switch understand routing also, right? And if a switch understand switching means L2 and L3 means routing also, we call that switch as a layer 3 switch, right? So in the next board, I will be showcasing you that how we can do the same thing on the switch, provided the fact that that switch is capable of doing L2 as well as L3, right? Previously, whatever the switch we had seen in the past 10, 12 years back, most of them was only L2. They cannot do the switching, so they cannot do the routing, right? But now, whatever the switch we see, they are fully capable of doing L2 as well as L3, right? But we need to tell this switch that now you are not only a switch, you have some extra capabilities. So if you see the TCP/IP model, right? Generally, switch can understand the physical layer and then the data link layer, right? But now we are saying, Mr. Switch, you can understand the network layer too, right? It means that we need to tell this switch that you have some extra power, right? And you have routing power, and that is why we need to write here in this switch configuration that Mr. Switch, now you can do IP routing also. If you do that and this device capable of supporting IP routing, then this switch will become router. Interesting. In this switch, you can create multiple VLANs, no doubt about it, because at the end of the day, this is the switch. But now you are saying that you are router 2. It means that it can do switching, means it can create the VLANs, send the packet based on the MAC addresses, right? But it can also send packet based on the IP addresses also, right? It means that the concept is going to be simple again. On these computers or the laptop, suppose this is 10.10.10.10/24 host, this one, right? I need to define what is the default gateway. Default gateway is going to be 10.10. We cannot change everything for this switch. Some of the concepts are going to be same. Every router, if this VLAN 10 wants to communicate to VLAN 20, which is 20.0/24, if that is the case, right? Again, we are communicating. We want to communicate between two different networks. If that is the case, we need to go out with the default gateway, which is 10.10.10.1. But now we do not have router. If we do not have router, then where this packet is going to go? And that is why we come up with another concept, which is known as virtual interfaces on switch. And that is why we call them switched virtual interfaces. So what we are going to do, we are going to create a switched virtual interface SVI over the switch, and we configure this as as 10.10.10.1/24. We can configure another SVI on this switch, which is having 10.10.20.0/24. We can configure another SVI which is for this network. So basically, this SVI is for green network, the default gateway. This is for the yellow network, and this SVI is for the red network, which is going to be 10.10.30.0/24, right? Or .1, right? How the communication now is going to happen. Now the switch, because you have enabled IP routing, switch has become the router also, along with the VLAN. So basically it is also start maintaining this table. Which table? The routing table. And now it is going to say, along with the MAC address, it is going to say that the IP or the network 10.10.10.0/24 is connected via, right, SVI interface. Interesting, right? So these interfaces are going to have name, right? Because this SVI is for VLAN 10, I will call this is for VLAN 10. This interface name as VLAN 10. So SVI or VLAN 10, it is as simple as that. 10.10.20.0/24 via SVI2, which is VLAN 20, 10.10.30.0/24 via SVI3, right, which is VLAN 30. It is as simple as that, right? Interesting. Now this is having the routing table. Previously it has the VLANs table also. The packet path is going to be, suppose VLAN 10 wants to go talk to VLAN 20. It is going to the default interface, default gateway, which is going to be 10.10.10, and everything is happening on the what inside this switch. So you cannot see, right? But yes, you can see the routing table of the switch, right? Interesting. I'm saying routing table of the switch. Why? Because you have made this switch as a IP routing, right? A router using IP routing command. If that is the case, it is going to be on this switched interface. Then basically it is coming here, right? And it is having another interface which is 20.0, and then basically it can route it here. Similarly, if this VLAN 10 wants to talk to VLAN 30, it is going to its default gateway first and then basically going here. Interesting, right? Interesting and easy too. Anybody has any doubt, any question on this, Mr. Dhaval?
Yeah, Vishnu, we have a question from Srivatsan. If modern switches are capable of both L2 and L3, does it completely eliminate the need of router, or do we still have to use the routers?
Yeah, so this is again a very, very interesting question, right? And the question is that basically if the switch can do both, right, L2 as well as L3, then do we need routers, right? Believe me, actually switches are used for the fast switching between your local area network, right? We are giving some more functionality to you on the switch so that you can do inter-VLAN routing, right? But most of the interfaces of the routers supports many things, right? Like if you want to connect it with the LTE interface, if you want to connect it to the 4G interface, frame relay interface, and so many things which are different, right? Which you do not find on the switch, right? Maybe we can merge router with the switch, right? But actually, on switch side, we are just giving you some more features so that you do not have to put a router here. But router's job is to deal with multiple routes, right? Believe me, a router on an internet is going to have approximately 5 lakhs to 8 lakhs route, right? And it is already there. And that is why your internet is working, right? Router has to deal with so many things which this switch doesn't have to, right? Because switch is going to have the similar interfaces, right? But router can be facing different type of network, different types of service provider, which you come to know. So definitely, if a switch can do the router work, and if we can have all those interfaces, there is no need of router at all, right? Or you can ask the other question, why can't we have more interfaces in the switch? Sorry, on this router, so that we can make this router as a switch. We can, right? When we call no two different devices, switches and router, these are fully capable of doing it, right? Switching and routing. The router can be a switch can be a router. There is no doubt about it. But let's keep their functions different, right? And this is how the Cisco's business model is, right? We create different routers. We can create switches. We are giving some extra power to switch so that they can also do routing inside your local area network, or basically inside a particular building. But definitely there are many switches which basically you do not need any router also. For example, in your data center, if we have all the Nexus switches, right? Those are fully capable of doing L2 as well as L3, right? And even we can connect directly these Nexus switches to the service provider also, because this supports multiple types of interfaces too. Your question is absolutely correct, and I'm just saying that right now we need both, because we have different type of network, and all the switches doesn't support all the type of network, and that is why we need routers too, right? Long answer, but it is what it is. Anything else we have? Dhaval? No? Yes?
No, Vishnu.
Perfect. So Inter-VLAN routing is done. We can do it via switches only. And Mr. Dhaval, maybe today, tomorrow, he's going to showcase you all this, right? But I want to give you one more interesting thing to solve, right? And Dhaval, I'm going to take another 5 more minutes, right? And then I will give you the access.
Sure, Vishnu.
So today, as I mentioned, that we are going to add some design hat also, right? To wear a design hat. Believe me, if you understand this much of networking, routing, switching, everybody says CCNA is just the basic. I would say if you complete CCNA, right? It is going means if I want to create a complete course on CCNA, it is going to be more than 100 hours, approximately 100 hours, I would say, right? And 100 hours in anything is going to make you ahead of 95% of people, believe me. And this is the main thing, that when we move upward in our career, right, we start forgetting these basics, and we start learning these basics whenever there is an interview, right, schedule. Do not do that. At least if you want to have your career, all these CCNA is a huge, right? Believe me, if you are CCNA, just do only 20% of effort, and then you will be CCNP, which is the network professional, right? Maybe you need more extra troubleshooting, maybe you need more extra labs. But believe me, if your fundamentals of CCNA are solid, then you just need 20% of effort to become CCNP. Maybe if you are CCNP, then you are going to become maybe 40% of effort to become the CCIE, right? Because it needs more detailed information. But if you are learning CCNA, if you want to learn OSPF, right? Why it should be only that 1 or 2 hours, which I am going to teach you right here because of the time constraints. Again, I have a complete course of OSPF also, which is explained in more than 17 hours, believe me, right? If you're learning OSPF, learn it fully, right? What is there for CCNA or CCNP? Why you are binding yourself? Why are limiting yourself that I need to study CCNA, and that is why I will be limiting only to OSPF and some of the nitty-gritties of it, right? If you are reading it from scratch, read it, right? If you learn this way, if you have a complete picture of whatever you are learning, then CCI is not far away if you want to do that, right? I'm not saying that you have to do CCI, you have to do CCNP, right? But that is going to be good for your career, because if you are CCI, if you are true CCI, then you basically everybody understand that you know things, right? This is a way of telling others that I know things. If you are CCI, you know things, right? So I'm just saying that if you are spending time 30-40 hours, right, and if you have resources, all the resources with you, if you're learning OSPF, learn it. Start giving some more time to it. Okay. So having said that, let's design a network, a pretty small network, maybe your home network. And you must be thinking that what is there to design? Everything works fine, right? Everything works fine. But do you understand the nitty-gritties, how it is working, right? Let's see that. So suppose we are having a small office where maybe 20 or 30 people are working. Very flat network, very small office, right? And I have drawn only 3 laptops, A, B, C. You have decided that these are going to be part of 192.168.10.0 network, right? This is host number 10.10, 10.20, 10.30. You all know for the sure, for the fact that 254 hosts can be here in this network, right? If this host wants to communicate with each other, definitely they can communicate via switch, no problems. And that is why you have purchased these 2 switches. This switch is having 48 ports, no doubt about it. You can connect 30 odd different machines to this switch. And these can start talking, right? If this guy A wants to share some information to B, he doesn't need to go to router, right? Only switch is capable of sending this information from here to here, from here to here, right? But now it is not all about communicating amongst yourself. You also want to communicate to other people in the world, right? Maybe your small business needs access to some of the websites, maybe Chat GPT. You are writing a code here, you are stuck somewhere, and now you're asking to Chat GPT that can you write this code for me? And it is writing. Very interesting thing, right? But how you are going to make sure that these routers are going to talk over internet, and that is why you have purchased a router here and you have given the first IP address in this interface so that if anybody wants to go out, they can reach to router first. And you have defined here the gateway. See, if you are talking to your known LAN, then basically no need of defining the gateway. But if you are walking outside to your LAN, we need a gateway, right? Which is this router, which is 192.168.10.1. We have to define by opening the TCP/IP properties of all these routers, right? Interesting. So suppose this wants to go to google.com, maybe 8.8.8.a, suppose, right? The packet which is going to come out is from the source IP address, which is this one, 10.30, and the destination is 8.8.8.8. The packet is going to reach here. And if this router has a route towards 8.8.8.8, it is going to forward it as soon as, right, towards the internet. Interesting. This router is also connected to the internet using this ranged 100.100.100.0, maybe .1 IP address here, .2 IP address here, and you have taken the services of Airtel. Airtel is giving you the Ethernet cable, and Airtel is saying that configure .1 at your side. I will be configuring .2 at my side, and just define a default route 0.0.0.0 and send everything towards me, towards .2. Whatever the packet comes to you, it should be going here. So this is the direction towards the internet, right? Anything. But here is my problem, right? And what that problem is, I will let you know tomorrow. But if I let you contemplate on that problem, I would just say there are three ranges of IP addresses, right? One is 10.0.0.0/8, right? It means that 24 bits are for the network, sorry, for the host. So many hosts can be here. The other one is 172.16.0.0/12 and 192.168.0.0/16. These IP addresses have been reserved for private addressing. And private addressing means anybody can use them. If you see your own network, right, home network, you are going to see an IP address from 192.168 range, right? And even I am having the 192.168 range address. And believe me, your IP address can be same as my IP address because this is the private IP address range. Anybody can use them, right? And if anybody can use them in this world, then basically there are more chances of collision of IP addresses, right? Then if that is the case, then how internet is going to communicate with me? For example, this IP address 192.168.10.30 can be used by my small office and it can be used by your small office, right? Maybe you are also using this 10.30. How come internet will be forwarding the IP traffic towards this and towards this? The forward traffic is not going to be problem because it is going towards 8.8.8.8, and if the server is somewhere here, this 8.8.8.8, the packet is going to be reached. The problem comes when internet wants to reach you, it is going to make your source IP to the destination IP, but now the destination IP is going to be 10.30. It is going to be the destination IP. When the packet is coming back from the internet, the source is going to be 8.8.8.8, and this 10.30 address range which you have given here, 10.10.10.30, it is a private address range. Anybody can use that, right? Or the range, sorry, this is range is 192.168. 10.30 can be used by anybody else. How do you send the packet back from this internet towards you and only you, right? I'm giving you the hint that there is a network address translation technology which can do this. Your router, which is at your home, actually doing this, right? So if you can read about NET before tomorrow's class, it is going to be great. If you can understand this network, how it is working, it is going to be great, because for sure you all understand now how switching the packets between this router. Now you all understand why these hosts are sending packets to our router, how router is going to forward this packet towards internet. There is only one piece of the puzzle which is remaining: how internet is sending back these packets to the private addresses which can be used by anybody. Okay, I leave this for you. Tomorrow we are going to design this network, right? Even we are going to increase somewhat complexity of the network, right? And then we are going to start OSPF in tomorrow's class. Having said that, I would like to take a pause here to take the questions. If you have any question, anybody having any question, Dhaval?
No, Vishnu. No
Okay.
questions.
So Dhaval, I am just stopping the recording. Bye everybody for now, right? And Dhaval is going to take care the what we can say the lab part. So 40 minutes class is still remaining. So be here to learn some cool concept on packet tracer.